found. And I want to subtract B from it, 1, 3, 5, 7, 9, 11. So the odd numbers. So 0, 4, 8, and 10. Okay, hopefully you did well on those. Now, the next part has a combination of 3 sets. And this is kind of getting us prepared for the next section. Now, if you remember in algebra, we simplify things in parentheses first. We're going to do the same thing in set theory. So we want to begin by finding A intersects C, which is actually our answer here. And we want to take B union that. So let me find B. Alright, that's the odd numbers. 1, 3, 5, 7, 9, 11. And A intersects C, 2 and 4. 2 and 4. Get that out of there. Okay, so the key is to do this first and then to do the union second. So when we go to do this one, we want to do first, second, third. So I think back here we have A intersects C and B intersect D, and we want to form the union of those two. That would be 2, 3, and 4. So parentheses say do me first. Complement of A includes 1 through 5, so we'd want 6 through 12. Okay, D union with that. Let's see, D contained 2, 3, 6, and 12. I don't know about you, but I get dizzy going back and forth. So if I union the A complement with the D, I'm going to have 2, 3, 6, 7, 8, 9, 10, 11, and 12. Okay. B complement, I think we found that. 0, 2, 4, 6, 8, 10, 12. Just transfer them down so that we won't get dizzy going back and forth. Intersected with the set I just found. So again, we want to do this one first, and then we're going to do this second. And if we didn't have B complement from up above, we'd also want to do that before we do the intersection. Okay, so we want to intersect these two, or do they have any? Okay, 2, 6, 8, 10, and 12. Okay, B intersect D. I think I might have that one. B intersect D. No, we haven't done B intersect D. Okay, so I need to do that first and then second. Okay, let me transfer C down here. C is 2, 4, 6, 8, 10, 12. 4, 6, 8, 10, 12. Now B intersect D. Getting dizzy again. 3. And that's it. So if I take C, okay, and remove any elements found in B intersect D, nope, we're just going to end up with C. Okay, if we take C and remove the elements found in A, C is the evens, so 2 and 4 would have to go, so we have 6, 8, 10, and 12. And so now we want the complement of that. Alright, so we list everything in the universal set not found there. 4, 5, 7, 9, and 11. Whew. Okay. Next we have what is called the Cartesian product of two sets. And it's actually a set of ordered pairs, A, B, where A comes from the set A and B comes from the set B. For example, if A contains 1, 2, and 3 and B contains X and Y, then A cross B, what we do is we match each element of A to an element of B. So 1, X, 1, Y, 2, X, 2, Y, 3, X, 3, Y. And that's our set of ordered pairs, and that would be A cross B. Notice that B cross A, we would start with, whoops, I'm thinking one thing and writing something else, X, 1. We're taking now our first coordinate is coming from set B. X, 2, X, 3, and then Y, 1, Y, 2, and Y, 3. And what you may note is the number of elements in A cross B equals the number in A times the number in B. So in this case, when I use this A and this B, 3 times 2 is 6. 3, 4, 5, 6 elements. So the Cartesian product, when we talk about the cardinal number, we simply multiply the number of elements in each of the two sets to come up with that. Alright, De Morgan's laws. The complement of the union is the intersection of the complements, and the intersection, or the complement of the intersection, will be the union of the complements. And the way you show these is by shading Venn diagrams, and I'm going to show you. This is something we'll be doing more of in the next section. So in this case, I need 2 Venn diagrams. And the way I can show they're equal is to shade both of them and then compare to see if I end up with the same thing. Now, one thing that I recommend on these is that you number the regions. Our textbook uses Roman numerals. I don't always do that, I will admit. And this is particularly helpful when you move on to 3 sets. Makes it a whole lot easier to deal with. So A union B would consist of what regions? It's going to be 1, 2, and 3. So the complement of A union B is everything else. So that is region 4, and that's actually our answer. I'm going to shade that. You want to shade the final answer, and only the final answer. Okay, now in this case, A complement is 3 and 4. Everything outside of A would be 3 and 4. 3 and 4 are both outside of A. B complement is everything outside of B. That's 1 and 4. And A complement intersect B complement. Whoops. Let me get back down. I kind of lost my page there. B complement is what they have in common. What do these two have in common? They have region 4 in common. And guess what? That's our final answer, so that's what we shade. And because of the fact we shaded the same regions in both of our Venn diagrams, that means that these two are equal. So you could prove the second De Morgan's law by the same process. Okay, again, the next thing you want to do is watch the sample problems for this section.